Hello students. In today's topic, I'll explain you about the resistance. In one of my video, I explained about the Ohm's law. Today we'll discuss about the brief about the resistance. What is resistance and on which, how many factors the resistance depends. Clear? So resistance. What is resistance means, the property of, the property of a material. Suppose this is the material. What is the material here now? Conductors. Gold, silver, aluminum, iron, material through which the charged particle can move freely, which are passing through it. It is said to be as a resistance. So here this is a material. Suppose here what happened inside the material conductor, some lattice ions also will be there. And electrons will be moving in a random direction. Not in a perfect direction, moving here and there, random directions. Clear? But when we apply the current to it, that means when we apply the current to it here with the help of a battery, then what happened? The charge is going in from here. This all the charges, electrons will move in the straight line at the time. Clear? Because externally they got the energy now. The current enters from here. And with the help of that current, this charge slowly move in this material here. Clear? The externally we are giving to it here, so it is called as EMF. EMF, electromotive force. Clear? Now, this is not the topic actually. Our topic is what are the factors on which the resistance depend. Clear? That will learn now. So mainly four topics are there. Four factors are there. How many factors? Four factors. Resistance depends upon four factors. Four factors. Clear? What are that four factors? First one, temperature. The first factor on which the resistance depends is temperature. Then the second one, nature of material. Nature of material. Nature of material. And third factor here, length of the material. Length of the material. Clear? And fourth factor is area of cross section. Area of cross section. These are the four factors on which the resistance depend. Clear? These are the four factors on which the resistance depend. So if we explain each one by one here now, it carries 4 marks. It can come for 4 marks or 6 marks. Essay type question, long answer. Clear? But very easy one. If you can concentrate on the topic here, on my lecture here, you can understand very easily and you can write the answer. You can frame the answer just by listening the lecture. Clear? So we'll discuss one by one. All the factors we'll discuss along with the table, along with the requirement, because this is the experimental based question, and maybe it is physics or chemistry or the biology here. Experimental based question should be framed in a perfect way. A systematic way is there. Aim, requirement, procedure, observation, conclusions, precautions. These all steps should be there. Particularly steps, if you mention this all thing, your answer will, you'll get the perfect marks also. Clear? So we'll start one by one. Temperature, the nature of the material, length of the material, area of cross section of wire. Clear? So we'll start from the first one. Clear? So how the question will come here now? How do you prove that resistance depends upon the temperature? Clear? How can you prove that resistance depends on temperature? Explain this. Explain with the help of an activity. With the help of an activity. Some activity we have to do. You have to explain briefly. With all the requirements you have to do. So how we have to write this here? Frame this answer now. Aim. What is the aim here now? To show that resistance depends upon the temperature. Clear? What the aim you write here now? To show that resistance depends upon temperature. Depends upon temperature. Aim. Then what is the requirement for this? requirements. Okay, to do this activity, to do this experiment here, what the things required? Okay, they are the requirements. So what are the requirements? The first one is ammeter, and second one is the voltmeter, and third is the switch key, and fourth is the battery. Clear? And fifth is the bulb. Clear? And the last and final is the insulated wire. Insulated wire. Clear? These are the requirements to do this activity. Which activity? We are showing that resistance purely depend upon the temperature. Okay, to show that we require this all the requirements. Okay, insulated wire. In home we'll use the insulated wire here, isn't it? This is the wire. This is the wire. Okay, this is the insulated wire. Now this is the copper wire inside. If you touch this one here, you'll get the shock. But if you touch here, you'll not get any shock here because it is insulated one. It is coated with the plastic or the rubber. These are the material which will not allow the current to pass through it. Okay, clear? They are the bad conductor of electricity. Already in lower classes we studied good conductor of electricity, bad conductor of electricity. Anyhow, these are the this is the conductor here. Okay, this is the wire. Okay, generally we use in the home. Clear? This one is the main copper wire here, and it is a insulated one. So like that insulated wire we have to take for this experiments. All the 4 experiments we have to take the same wire here. Clear? Now we have taken this whole thing here. Then what are the next here now? Next one is the first. First aim you should write. Okay. Second requirement you should write. And what are the third you're going to write? Procedure. Okay. Procedure. What you write in the procedure? Always remember. Okay. Maybe it is physics or biological science or the chemistry. In procedure, the first 2 points should be arrange the apparatus as shown in the figure. Arrange the apparatus as shown in the figure. Arrange the apparatus as shown in the figure. That you have to write compulsory in all the experimental based questions. Now we will arrange this apparatus now. Which apparatus? This all requirements what already we have taken. That will arrange now. Okay, these things will arrange now. Clear? So here, here I'll draw the diagram. We have to make one circuit. This is the circuit. Clear? So this all thing we have to introduce in this. Okay, in the circuit here. What first thing what we are keeping here now? Bulb. Okay, a bulb is here. Okay, a bulb we are keeping the circuit here, and here switch key is there. Here we are keeping the switch key here now. Here battery. Okay, a battery we are keeping here now, and here the instrument we are keeping, that is ammeter. Okay, and here you are keeping the voltmeter. This is the voltmeter. Clear? Ammeter. Okay, voltmeter. Okay, switch key. Okay, battery. Okay, insulated wire. This is the wire. This wire is insulated wire. Okay, these are the things we have introduced here. Okay, battery when you are keeping here, show the signs also, positive and negative. This is the battery. Battery. This is the key, switch key. Clear? So where the positive is there, from there only the current moves. Okay, from the negative it comes and moves from the positive. Clear? It moves like this. Okay, once again it makes a circle. Clear? And this one is the battery. Okay, this is the battery. Clear? This one, can you see here clearly? This one. Okay, this is a positive, and this one is the negative. Okay, current moves from here, from negative to positive, and then move. It makes one circle, a circuit. Okay, battery. Clear? Now, here we kept the bulb also here. Okay, clear? In procedure, what the first point here written? Arrange the apparatus and show in the figure. Now we have arranged the apparatus. Clear? Now the next one, next point in the procedure now. Clear? Procedure, what we are doing here now, we are arranging whatever the requirements we have taken, that requirements we have arranged in systematic way. Arrange the apparatus as shown in the figure. We have arranged. Then observation. The next one is the procedure, the fourth, then observation. Observation. For observation here, we have to make one small table here. Okay. Serial numbers, and then voltage, current, resistance we have to show. That is V by I. This we have to show here. One table you have to make it. Clear? Clear? Now first one. Okay. In the beginning here, what happened here? Switch on the key. Okay. On the key here. Once you on the key here, the current starts. Okay. The current move, the charge move here. So work of ammeter and voltmeter, they show their readings now. And one thing you remember always, ammeter should be connected in series only. Voltmeter should be connected in parallel. Okay, in parallel. Both will show the readings now. Ammeter as well as the voltmeter. Voltmeter potential different, it will show here. Ammeter current, it will show here. Okay, what is the work of ammeter and voltmeter already be completed. In one of my video, I have explained detail what is the work of this ammeter and voltmeter. Okay, directly we'll go to the topic now. So ammeter will show one reading and voltmeter also will show one reading here now. Okay, now note down that readings here. Okay, the first one, suppose 15. Okay, voltmeter is showing the 15 voltage. Okay, current 5. Okay, what the current is showing, 5. Then if you want to know the resistance here, R equal to V by here. So 15 by is equal to 15 by 5. So how much you are getting here now? 3. This 3 is called as 3 ohms. Okay, like this will measure current, electricity here. Clear? This is the first one. Clear? First reading. Switch on the key. Then once the current move here, you can know the reading here in ammeter as well as in the voltmeter. Here you got the readings, both the readings 15 and 5. Then we got the 3 ohms. Okay, we got it that what is the resistance here now? 3 ohms. So after that, don't do anything for the 40 minutes. For 40 minutes, what happened? Leave this complete setup like that only. For 40 minutes, 45 minutes, leave the setup like that. Don't touch it. Don't do anything to the total experiment. It's gone. Let it be gone. So after 40 minutes or after 45 minutes, then once again come. Don't on anything. It is already going on. Bulb is already glowing here. Clear? After the 45 minutes come and once again check the readings in ammeter and voltmeter. It will be different now. Okay, it will be different here now. So the second, after 40 minutes, second time we are checking the reading here now. Okay, so what the reading here now? Suppose 25 here and 5 here. Clear? Clear? Then check it out here, resistance. To know this one, what we have to do? 25 by 5. So what you are getting here now? 5 ohms is the reading. Okay, both the readings are changed now. Okay, starting it was 3 ohms only, but now check it here, 5 ohms. We have not done anything in this circuit here. Nothing we have done here. We have not kept the second battery here, or nothing is done in the circuit here. Nothing is done in this activity. Okay, nothing, any new thing is added to this experiment here. But then also current increases. What is the meaning of this current increases here now? Because of the temperature increases here. Okay, continuous glow of bulb. It is not only giving the light, it also produces the heat also. And due to that temperature, the resistance also increases. Okay, when the temperature increases, the resistance also increases. Keep in the mind, when the temperature increases, the resistance also increases. And if the resistance increases, current decreases. This you have to keep in the mind. Okay, if the resistance increases, then the current will be reduces. Okay, anyhow, this experiment tells that if the current increases here, then simultaneously the resistance also will increase. By this activity, we can say that okay, the resistance purely depend upon the temperature. This is the first factor. Clear? Resistance purely depend upon temperature. Clear? Resistance depend upon temperature. Clear? Understood? Clear? These are the two readings. First reading, after first reading, leave some time. Give some time to the experiment. Okay, leave this total setup aside. Okay, for just 40 minutes, 45 minutes. Then after that, without doing anything to it, just check the readings in the ammeter and voltmeter. When you check the readings, both the readings here, then the readings will be little bit different. That different only because of the extra heat it is produced in the bulb. The temperature increases here, and if the temperature increases, resistance also increases. If the resistance increases here, what happens here? Current current will be decreases. This is the main reason in summer season, power cut will be there. ड्यूरिंग समर सीजन बहुत सारे एरिया से हमारे जहाँ पे करंट ही चले जाता है, 2 घंटे के लिए करंट निकाल रहे, 4 घंटे के लिए करंट, थोड़े को 7 घंटे के लिए, 2 घंटे के लिए. ये करंट पावर कट क्यों हो रहा? जहाँ पे पैदा हो रहा करंट, जहाँ पे एक मशीनरी से पैदा हो रहा करंट, इट इज कमिंग इन द वे. ओके, करंट कैसे सप्लाई होता है? बड़े बड़े वायर से सप्लाई होता है. बिग वायर्स विल बी देयर. हैव यू सीन वायर पोल्स, इलेक्ट्रिक वायर्स, मोटे मोटे वायर्स होते हैं, बिग वायर्स है. ओके, समर सीजन heat will be nearly 45 degrees, 40 degrees, 45 degrees temperature, and in that wire 250 volt, okay, 250, 300 volt, 400 volt, okay, voltage also heavy voltage plus temperature also heavy temperature. Then imagine the wire, okay, the resistance will be too much high, okay, too much high. So if the resistance is too much high here now, then what happens here now? The current will be slow, the movement of charge will be slowed down, the current will be slowed down. That's the reason power cut will be there here. Other reason I'll tell you, in this high voltage wire, too much high voltage wire, have you seen any time the birds will sit on that? Have you seen? Even it is a high voltage wire it will be, but birds can easily sit on that. Clear? Then also they'll not get any current at all. They'll not die here. Sometimes some birds will die. Do you know why? Because when the bird sits on that here, main high voltage wire, okay, main high voltage wire here, if they sit on that here, if their tail touch to the other wire here, what happens here? Potential difference creates here, then it will die. Even if we also touch the wire here, don't touch it. Yes, if you example for जाके कहीं wire को पकड़ लें, you should not do that thing. Okay, just example. Even if human being touches the live wire, okay, and without touching to the ground, your part of the body should not touch to any other thing at all here. Then nothing, shock, never. Okay, you will not get any shock at all here. But if your body touches the ground, then ground potential level, potential difference, and wire potential difference will be different. There the potential difference creates and you'll get the shock. Same bird. That's the reason birds easily sit on the live wire. Okay, 250 volt, 300 volts, 500 volts. On that easily the birds can sit. Clear? That is not our topic. Our topic is that if the temperature rises, resistance also rises. Clear? Increases. And if the resistance increases, the current reduces. This is the first one. Now we'll do the second one. This is the first factor. Temperature is the first factor. Okay. Next one. In all the experiment activities, table is must. You have to note down all the values, readings, which is in ammeter and the voltmeter in tabular form. It should tabulate it. Clear? What is the next one here? What is the next topic? What is the next factor here? Temperature already we have done. Okay. Now there is no work of a bulb here. Why I left the space, I'll tell you. Okay. No need of the bulb there. Clear? The next one is the nature of material. Okay, resistance depend upon nature of material. Nature of material. Nature of material. Okay, whether the resistance depends on the nature of material or not. Second activity. In this activity here, same thing, aim. What the aim you have to write? To show that the resistance depends upon the nature of material. Okay, requirements. What are the requirements? Ammeter. Okay, voltmeter. Okay, this is the ammeter and this is the voltmeter. Okay, battery, switch key is there. Okay, insulated wire, this insulated wire here, and the nature of material. The next one is what we have to take here. Materials will take 2-3 materials will take. The first one will take gold. Second one silver. Okay, and third one aluminum. Okay, 3 materials we are taking. Materials here they're acting like a conductors now. Okay, clear? So three materials we have taken here. Okay, now here we have to show that whether really the resistance depends upon material or not. Nature of material, it depends on that or not. That we have to show here. Same thing, arrange the circuit here. Okay, by taking this all requirements. Okay, ammeter, voltmeter, insulated wire, battery, key, and this all three. At a time, three we should not keep all conductive. You use the gold one first. Okay, keep here gold. Here gold act like a conductor in the first activity. Okay, in this first one, what we kept here? No gold. Here we kept the gold conductor as a conductor gold here. Now note down the reading, switch on the key here. Now the current starts. Okay, note down the current here and here. Both you current note down. Okay, so serial in the first serial, what we kept here? No gold. First one we kept here gold. Okay, here 16 you got. Okay, and this one is 8. Then show the resistance here. How much you are getting here now? 16 by 8. So 2 ohms. You got the 2 ohms here. Okay, in the second we are keeping the silver. Okay, silver. Now here 20. Okay, 5. Okay, voltage is 20, current is 5 ampere. It measured in ampere. Now what will be the resistance here now? 20 by 5. So how much you are getting? 5 fours are 20. 4 ohms. Clear? Silver. Then third one, aluminum is there. Aluminum is there here. Okay. Now aluminum here 30. Okay. Then here 6. Then check it here now. This is only for the example. These numbers you will not get. क्लियर? ये नंबर्स आती है नहीं, ये सिर्फ एग्जाम्पल आपको समझ में आने के लिए बता रहा हूँ. एक्चुअली जब हम बैटरी यूज करेंगे ना, उसके मेजरमेंट अलग रहते हैं, उसके रीडिंग्स अलग रहते हैं. इट रीडिंग्स विल बी डिफरेंट, टोटली डिफरेंट है. ओनली टू अंडरस्टैंड द पैटर्न या कॉन्सेप्ट, वो बताने के लिए बता रहा हूँ बस. ठीक है, कॉन्सेप्ट आपको अंडरस्टैंड हो गया तो रीडिंग जो भी रीडिंग दे आप कर सकते हैं. You can do easily here. Okay, this only to understand the concept here. So 30. Then what you're getting here? 30 by, to find out the resistance, 30 by 6. Then what you're getting here? 5 ohms. Clear? 2, 4, 5. Okay, all the readings are different. Clear? All the readings are different. Just by seeing the readings, you can tell here what is happening. Yes, definitely resistance depends upon the nature of the material. Okay, each material. Okay, they're all the material only, but their properties are different. Nature. Okay, the nature of these materials are different here, and because of there's a property of gold different from silver, property of silver different from aluminum. Okay, properties of aluminum different from gold, even though they are material only. Even we are using as a conductor only here, but their properties are different here. Because of that, what happened here? The resistance also will be different here. Clear? Resistance also will be different. Clear? Understood about this one here? This is about the nature of material. Clear? Then what the precaution you write here now? For all the activities, you have to write the precautions. Okay, when you are showing this table, that is nothing but a observations. Okay, when you are showing your readings, okay, that first reading is so much, second reading is so much, third reading is so much, fourth, five, whatever you're showing here, no, that means you're observing, something, observations going on here now. Okay, in ammeter and voltmeter. Okay, so there is observation. After observation, what are conclusion? What are the conclusion? What are the conclude? Okay, we'll conclude that yes, the resistance totally depend upon the nature of material. Clear? Resistance depends upon nature of material. There is a conclusion. Then finally end that answer with the precautions. What are the precautions you have to take? All the 4 activities you have to have the precaution compulsory. Okay, what are the precautions here now? What are the experiment activities you are doing now? This activity should be away from water bodies. Away from water bodies. Okay, whatever the activity we are doing here, electricity activity if you are doing, करंट के कोई भी एक्टिविटीज करो, पानी की खरीद नहीं करना वरना शॉक लगता. इसलिए we should do this type of activities, especially for electric activities here, no, that experiment we should do this away from the water bodies. First one, this is the first precaution. Okay, second precaution here, it should be away from electrical appliances. Away from electrical appliances. Electrical appliances. What are the electrical appliances here? Fridge is there. Okay, big heater is there. or any instrument which have the magnetic field in that. So due to that magnetic field, maybe it affects on ammeter and voltmeter. This ammeter and voltmeter will not give the perfect reading then. If you are very near to any big instruments, fridge are there, TV is there, LCD like that, if you are near to that, inside that instrument, electrical appliances, the magnets also will be there, their power also will be there. It definitely affects on the reading in ammeter and voltmeter. Okay, so this is the second precaution. Third precaution, what the ammeter and voltmeter you're using, this device, it should be updated. Okay, if it is updated, then it can give the accurate value. Okay, accurate reading it can give, a perfect reading it can give here. So it should be updated. Okay, updated ammeter and voltmeter should be used. Clear? Updated ammeter and voltmeter should be used. Clear? And the fourth one now, finally fourth one. What are the fourth one? Update over, away from the electronic and water, Last and fourth, which is a very important, that should, this wire should be insulated wire. The wire should be insulated wire. Just now I have shown one wire to you. This is an insulated one here. So these are the precautions. These are the 4 precautions. Clear? What are the precautions? Away from the water bodies. Okay, away from the electrical appliances, and your devices, what you're using, ammeter and voltmeter, it should be updated. It should be good in condition so that it can give you accurate readings. Clear? And finally, what the wire you are using here as a conductor here, that wire should be insulated wire only. Clear? This is the next one. Clear? This proves that, after this experiment, it proves that here resistance purely depend upon the nature of material also. This is the one of the factor for the resistance. Next one we'll do. Third one. Next one we have to show that, or how can you prove that resistance depends upon length of the material. The next topic, third one, is the length of the material. Length of the material. This is the third one. Whether the resistance is depend upon length of the material or not. For that, once again, the activity. Okay, so again the activity we are doing here now. Clear? So what we are taking here, same thing. Like other activities, 2 activities we have completed here. In this also the same thing. Aim what you write here. Okay, to show that resistance depends upon length of a material. Length of a material here. That's here to show that resistance depends upon, okay, length of the material. Clear? Now what are the requirement for this experiment? Same requirements. Okay, only 1 or 2 things will be changing here. Remaining will be 90% is same. Clear? So what are the requirement we are taking here now? Ammeter. Okay, same you have to write ammeter. The first one is ammeter. Second is voltmeter. Voltmeter. Third is switch key. Switch key. Okay. Fourth is insulated wire. Insulated wire. Then battery. Battery. Then here we are taking the copper wire. Now listen carefully. The next 6th one is important now. Okay. Here 6th one is important here. Here we are taking the copper wire. Which wire we are taking here? No, copper wire as a conductor. Okay, here we are keeping the copper wire here. Length of the material, length, it differs the length here. Copper wire taking here. So in the first, what happened? We are taking 2 meters wire. How many? 2 meters in the first case. The second case, 40 meters of wire. Third case, 60 meters of wire. Clear? 40 meters, 60 meters. This is the length of the wire. Okay, that only we have to show here, length of the wire, whether it affects on the resistance or not. That we are going to show here now. Clear? So these are the different. Okay, material, conductor is same, copper only we are taking. Material is copper only, conductor is copper only, but that copper wire length is different. One is 2 meter, imagine 2 meter wire, then 40 meter wire, then how much 60 meter or 100 meters wire. Okay, big wire here. Now these three wires are here. Now same thing once again. The next after requirement, the third will be the procedure. Procedure. What do you write in the procedure? Arrange the apparatus as shown in the figure. The first point you have to write it. Arrange the apparatus as shown in the figure. This should be the first point. Okay. Then the next. Clear? What is the first line you have written in procedure here? Arrange the apparatus shown in the figure. And then switch on the key. Okay, we arrange everything here now. Clear? Then we are switch on the key. First we are keeping the 2 meters wire here. Okay, 2 meters wire. Which wire? Copper wire. Which wire we are using here now? Copper wire. Copper wire. What is the length of copper wire here? 2 meters. In the first case here. Now write in the table form. Okay, serial number, conductor, voltage, current, resistance, V by I. This we have to show, isn't it? Now, the first one, in the beginning, the first one here, what we kept here? 2 meters copper wire we are keeping here, length. So, conductor here, copper only we are taking here. How much? What is the length of the copper wire here? 2 meters. Okay, length of the copper wire is copper we are using. You can write here. Copper wire you are using as a conductor here. Okay, and length of the copper wire is 2 meters in the first case, first experiment. So, what the value you are getting here now? Example 35. Okay, then here 7. Clear? So what will be the resistance here now? 35 by 7. 7 5 is a 35. 5 ohms. First reading. Okay, now change the next one. Okay, change the 2 meters wire. You take out this one here and keep the 40 meters now. 40 meters wire. Okay, 2 meters already you have done. This one completed. This one completed, and we already got 1 ohms. 5 ohms you got it here. Second reading. Okay, second reading. How much length we have taken here? 40 meters we are taking here. How many? 40 meters. Now here voltage, maybe voltage 40. Okay, then 8. Then check the resistance here now. How much? 40 by 8. So how much you are getting? 5 ohms. Okay, wait, we'll change here now. Clear? Because already we have done this one, same ohms we are getting here. So next one, length of the wire here, copper wire is 40 meters here. So here we are taking 60. Okay, then 10. Then check the resistance here now, 60 by 10. 10 6 is 60. 6 ohms. Clear? Next one, third one here, 60 meters are there. The length of the wire, copper wire is 60 meters now in the third case here now. Okay, once again switch on the gear, everything starts here. 40 completed. Now we are taking how much here now? 60 meters. 60 meters of wire. Okay, now again we are doing the experiment. We got the 64 here. Okay, 8 resistance here to find out here. 64 by 8. How much you are getting here now? 8. 8 8 is 64. Clear? 5 6 8. Okay, all the readings are different here. All the readings are different. Why the readings are different here now? Because what happened? The length of the wire is different. Okay, the length of the wire is totally different. Clear? Length of the wire, if the very small wire here, okay, the resistance will be small. Okay, if the length of the wire increases, okay, the resistance also increases then here. Listen carefully here. So length of the wire, if it is increases, then here one we can write here that R length of the wire. Listen carefully. When it is moving already, we have note down this reading here now. Length, when the length is very small here now, the current can easily flow. Okay, the resistance will be very less. But see the 40 meters here, the resistance will happen slowly increases. Length of the wire is slowly going up. 60 meters here, heavy wire, too much here wire, all the coiled wires. Okay, in home if you want to connect any bulb like that here, if you take 10, 60 meters, 100 meters wire and connecting here, wasting of one is the wasting of the total wire here and electricity will be wasted here. Clear? So This here shows the readings, different readings, 5, 6 and 8 here. So here what happen, if the length increases, what happen here, if the length increases here, the resistance also will be increased. If the resistance increases here, current will be decreases. Clear? Understood about the length here? If the length increases, what happens, the length of the wire, if it is increases here, the resistance also increases here. If the resistance increases here, the current will be decreases. Clear? This is about the here. Okay, so we can say that after this experiment that length of the resistance depends upon the length of the material. These are the material. Material we are taking the same, only one only, copper material only, but only length is different here. Okay, the length is different. So what we can write here, resistance is directly proportional. Okay, length is the directly proportional to the here resistance. Resistance directly proportional to the length of a wire. Clear? If the length increases, the resistance also increases. So it is directly proportional to the length. The resistance is directly proportional to the length. Clear? This proves this that resistance depends on the length of the material. Apparatus same here. Only wire we have taken, copper wire we have taken of different length. Clear? This table is very important. Okay, for each and every activity, draw this table. Table is important. Clear? Table is very, very important, because this table shows the readings. Okay, shows the readings in ammeter and voltmeter, and resistance also it shows. Clear? Length of the wire is different. Okay, length of the wire, the material is different, so your resistance also different. Resistance also will be different. Length increases, resistance increase. If the resistance increase, current will be reduced. So here we can say that R, that is resistance, is directly proportional to the length. Next one. What is the next one? The next one, last one here, no? Finally, the last factor. 3 factors already we have completed. Now the last factor here. What is the last factor here now? Area of cross section. The last one. Okay. Area of cross section. Cross section. Cross section of wire. Okay. Cross section of wire here. Now what we have to take here now? Aim. Same procedure is same, okay. Aim, what the aim you write to show that resistance is depend upon the area of cross section, whether it is depend on cross section or not. Yeah, that one. Then to show that resistance depend upon area of cross section. Clear? Next, requirement. Okay, what is the requirement we are taking for this experiment here now? Same all the requirements here. Okay, the first one is ammeter. Okay, the second is the voltmeter. Third is the switch key, and fourth, battery. Fourth is a battery, and fifth one, clear. What we missed here now? Ammeter, voltmeter, switch key, battery, clear, and insulated wire. Okay, then sixth one here also, this one is very important again. Okay, here also we are taking the copper wire as a conductor. Here also we are taking the copper wire, but this copper wire, okay, the area section of this copper wire is different here. Okay, first is very thin. Okay, like this one copper wire we are taking here. This is the area of section. Second, little bit big, small, and medium. This is a medium size copper wire. Okay, then the big one, large one. These are the 3 wires. Clear? Small, this is a small one. Small copper wire here with the small area section of copper wire here. This one is the medium one. Okay, medium. This is the large. One. Okay, like this. These three examples I'll show you. Small. This one is small. This is a copper wire. Material is copper only. Copper only we're taking. But cross section means this one. This is the cross section of that. Okay, this is the cross section. Area of cross section of this copper wire. Okay, this is a small one. Clear? This is small here. Now this is the medium then. This is the medium. Clear? This is the medium. Small, medium. This is the medium. Now this is the large. This is the large. See the area of cross section here. This is a large. This is the medium. This is the medium. This is the small. होप यू कैन अंडरस्टैंड हियर. समझ में आ रहा है ना. इसका एरिया ऑफ सेक्शन देखो छोटा है, इसका इससे थोड़ा बड़ा है मीडियम, इसका और बड़ा है ये लार्ज. क्लियर. ये इसका जो एंड पार्ट है ना इसको बोलते हैं इसका विड्थ, इसको बोलते हैं एरिया ऑफ क्रॉस सेक्शन ऑफ वायर. विच वायर? कॉपर वायर. ऑल थ्री आर द कॉपर वायर्स ओनली हियर. नाउ विद दिस विल डू द एक्सपेरिमेंट once again. So this here, then what is the next one? Procedure. The next step will be the procedure. Procedure here, arrange the apparatus as shown in the figure. Clear? What you should write in the procedure, what should be the first point in the procedure? Arrange the apparatus as shown in the figure. So arrange this, all the arrangement requirements in the proper way. Okay, as shown in the figure. Figure you have to draw. Okay, we are doing the activity practical. If you are doing the, definitely you have to arrange this all apparatus. Okay, next what we have to do here now, observation now. Already you have arranged your apparatus, everything is ready now. On the switch key, when you on the switch key, we'll see the observations. Clear? What the observation we'll see, what we'll keep in the first? Copper wire only we are using here. Okay, copper wire we are using here as a conductor. Copper wire we are using as a conductor. But the area of section of this copper wire is small. Is small here. Okay, with this we'll start our experiment. The first one. So on observation, serial number. Okay, conductor, voltage, current, resistance we have to find out. V by I. Clear. Now in the first case, what we are using, we are doing the copper wire only, but that copper wire, the area section of that copper wire is small, very small here. This is the first one. Small. Okay, which conductor we are using? Copper. Copper as a conductor. This copper wire of this area of this copper wire section is small, just small here. Now note down the reading. Already you on the switch here. Now note down the readings here. Okay, what you'll see the readings here now. Now suppose here 15. Okay, 5. Then what will be the resistance here? 15 by 5, 3 ohms. Clear. Now the second one, same copper wire we are taking, but the area of cross section of this copper wire is medium, not big one, not small one, but it's a medium. Okay, medium area of cross section. So this one 8, 4. Okay, resistance, how much you are getting? 8 by 4. 4 ones are 4 twos are 8. 2 ohms. Clear? 2 ohms. Now the next, in third condition, in the third set, we are taking the large. Okay, same conductor, copper wire only we are taking here, but this copper wire, okay, area section of this copper wire in the third set, it is a large one here. Clear? This is very small. This is a very small. Okay, this is the medium one. Okay, medium one here, and this is the large. Okay, large one. Well, this is the difference here. Clear? So large one. Now here what we are getting here now 5. Suppose 5 and here 4. Now what will be the resistance here now? Okay, 5 by 4. You'll get 1.2 ohms. Clear? See the difference here? Okay, see the difference of resistance here. Okay, when the area of copper wire conductor becomes, the area of cross section of this copper becomes large here, big here now, automatically the resistance decreases. Resistance decreases. When see the resistance in the first case, very small here. Copper wire area section is very small here. Then the resistance is 3 ohms. Like that 2 ohms, then 1.2. So what it indicates, if the thin wires are there, very thin wires are there, okay, there what happens, the resistance will be high. Okay, the resistance will be very high. But gradually, if it increases the area section of a copper wire, big one here, what happens at that time, the resistance also will be less. Clear? When the resistance is very less, flow of current will be increases. Clear? Big wire, that's the reason the big wires are used for the electrical departments. Okay, outside, can you see the electrical wires will be the big one. Okay, high voltage wire. Okay, the same wire we can't use in the home. Okay, for our phone to do the recharge of phone here. Okay, sorry, not recharge. Okay, charging of the phones. If you do a charger will be there. Na? See the wire of the charger here, very thin. Headphones. See the wire of headphones here, very thin. We can't keep such a big loaded wire. We can't keep here. So when the size of this area section of the wire increases, what happens? The resistance will be decreases here. Clear? So what you'll write here now? In one word, you can write that resistance. Resistance is the inversely proportional to the area of cross section. This you can maintain here. Clear? Resistance is inversely proportional to the area of cross section. This you can write here. Clear? So this is the experiment. Here the experiment is concluded here. Now I'll show something different here now. Now length, resistance depends on the length of the material also, isn't it? So there what we have written here, resistance is directly proportional to length. Okay, same thing you written there. Next one, area of cross section, what you written here, resistance inversely proportional to area of cross section. Area of cross section. Now commonly in both we take out the common here, you can write the resistance is proportional to L by A. Clear? If you take out the common here, in both here, it will be like that. Okay, resistance is proportional to length by here. Now make it this everything in a constant way. We have to show in a constant form here. So what we have to write here now? If you remove the proportional there here, directly proportional or the inversely proportional, then you have to make it as a constant. Okay, constant. So what you'll write here now? R resistance is equal to rho L by A. This is the final one. Clear? This is the constant. Clear? What is rho? This symbol is called as a rho. This is rho. Just look like a P here, but it is not a P. It is a rho. Rho means RHO. It is a Greek letter. Okay, it is a rho. It is nothing but it is called as a specific resistance. Okay, rho indicate that specific resistance or resistivity, you can tell. Okay, resistance or resistivity, you can tell here. Clear? These are the 4 activities. Clear? Through these all 4 factors, okay, on which the resistance will depend. Clear? Now further, this whatever you have written here, okay, rho, resistance, length here, now, depending upon this here, we'll do some numericals. Okay, some equations also are there. Clear? We'll do very soon. Clear? Thank you.